right. I'm going to give you a bit of a chat about a game of whack-a-mole we play on the Betfair gambling exchange. I work for the sort of Betfair side of the business, just to give you the obligatory who we are slide. We're a group, Paddy Power Betfair. We're about 7,000 people. We have brands covering quite a bit of the world. The side of the business I work on is Betfair. We invented the gambling exchange, so if you don't know what one of those is, in a normal fixed odds bet, you'll make a bet against a bookie. In a gambling exchange, you'll put up a price for maybe a horse to lose, someone else will put up a price for a horse to win, and we match those two bets together and take a commission from the whoever wins, I guess. So last time we had a look, we're quite a big gambling exchange. We handle more transactions than all of the European financial markets, or the financial exchanges. What that means is we have effectively one of the best or cleanest sources of crowdsourced price for sports in the world. And people like stealing our data. Hence, we have a game of whack-a-mole that we play. So, a bit of background. We're a company, we supply market prices to people. Not all the people are acting in good faith. These are the kinds of people we like, so customers of our exchange. We supply prices to our internal fixed odds systems so that our sportsbook can get better pricing. We have white label business to business, market data sharers, and we have customers in emerging markets as well. There are a range of poorer actors out there. We have competitors in the fixed odds space, in the exchange space. There are various pop-up exchanges and sportsbooks that appear in places like India and Pakistan. The figure we kind of get quoted is there's sort of 50 at any time, and they'll just pop up, run a book, take money, and then disappear again. That's not really good for our business model. And there's people that just sort of abuse fair usage constraints. So what do you do about that? Much like the video market where you rent a DVD or a Blu-ray, you probably know that those discs are encrypted. The problem being that if you supply a video to somebody, you want them to actually watch the video. So you have to maybe supply them with an encrypted disc, but you have to supply them also with a decryption key so that they can watch the video. Generally, I don't know how long it took for Blu-ray, but I think it was days after the release of the platform, the decryption key was made available on the internet, and suddenly video piracy kicked off again. And we have effectively the same problem. In order for our business to work, we have to supply our market pricing data to our customers. So the only real way of fixing the market data leakage problem is to play whack-a-mole, to detect people who are abusing our data and stop them. So a little one-on-one, a 101 of how you do mole whacking. This is kind of a model of how we think about these kinds of problems. We have systems of record. So these are systems which perhaps hold our pricing data. We have systems of insight based on the view of customers reading our market data. We might be able to produce some kind of insight as to who might be a good actor and who might be a bad actor. We then make some kind of decision about what we gleaned from the insight, and then we do something about it with a system of engagement. This is what the world looked like maybe a year or so ago. We had a data warehouse, which we pumped all of our data in, and I'm sure most of us have data warehouses. A bunch of SQL, manual SQL, weird table joins and what have you was done on that data, which generally took hours, if not longer. A human would have a think, and then maybe close an account. The average time to closure was 6 days. So if you think about a gambling business, if you're a new customer, we'd like to sign you up and get you to make a bet. Generally, we don't want to make that a long and involved process. It generally takes seconds to sign you up and get you onto your first bet. Well, you can do. We'd like you to, in fact. So 6 days to closure is pretty bad. What we were seeing, and we ran a number of experiments, particularly with our rivals in the gambling industry, was that we could alter the pricing on a rival's website, and in fact we could alter the names of the horses on a rival's website just by changing our data. Right? And that happened pretty quickly. So, it's still happening today, but we needed something just a tiny bit faster and a little bit better than this. And this is where KX came in. Right. So when you play whack-a-mole, you want to make decisions fast and you want to make them accurate. So in not 6 days, we wanted to be able to respond to customer behaviour in seconds. We wanted to use the accumulated expertise that was in the head of one guy in particular. You know, we've got all this knowledge in this guy's brain, he's a great expert, and we wanted to encode it somehow in our system. We wanted to set up a set of business rules to mimic that guy's knowledge. And in fact, he's training our system at the moment. We wanted to be able to change those rules in a matter of hours. We wanted to be able to implement new detectors to look at potentially aberrant customer behaviour so that we could act on it in a matter of days. And if we wanted to change our entire design pattern, we wanted to be able to do it in weeks. One of the things that we decided to do as part of this solution was to use a traditional AI technique. We used a thing called a BRMS, what in my day was called an expert system. So we have a set of if-then-else type statements encoded in a set of business rules, a rule engine. We also wanted to implement machine learning. We've got a problem that maybe some of you don't, in that we have a glut of data hitting us, and almost none of it's labelled. So how do you detect the bad actors in a huge amount of data with a machine learning algorithm? We can do clustering and so forth, we can do unsupervised learning. But what we wanted to do as a part of this project was start building that training set. So we wanted to put a human in that loop. We would present information to that human, suggesting maybe we close an account, and have them act upon it. We're currently collecting that data set. We're not quite in ML yet, but we're not that far off. And we wanted the usual people, process, technology stuff so that we could manage it properly. So, why did we pick KDB+? Our relationship with KX is maybe a yearish, a little bit more than a year now. We have quite a lot of data and it moves very, very quickly. So in terms of pricing requests, 130,000 transactions a second is not unknown. We stream data. So one of our problems that we recognise when big events like the Grand National happens is that most of the time, if you're running a bot or something against our gambling exchange, every time you poll for a new price, most of the data you're getting was the same as the old price that you asked for 100 milliseconds ago. So we built streaming APIs so that you could only get the price changes. You would subscribe to a pricing feed. We do about 130 megabytes per second compressed of streaming price data to our customer base. We take, peakish 7,000 bets per second. So you can see, if you want to do real-time analytics on that, you've got a challenge. We went to the market, we looked at a bunch of different vendors. Some were quoting us 70 CPU cores just to ingest that feed of data. We are ingesting that with less than 1 core in KX. So it became an absolute no-brainer. I mean, the solution kind of sold itself. There you are, sold it for you, Kev. It really was a no-brainer. So what we needed to be able to do is not just ingest the data, which is easy, pump it into a database or something. We needed to be able to process in real time. And that, I'm happy to say, we're doing today. So what we built is a whack-a-mole orchestrator with the catchy name Whammo. I'm very proud of that name, by the way. So we needed to show the business that we could do something. We ran up a hack day. A couple of members of the hack are actually in the room at the moment. Good mind, or good fellows. We built a proof of concept in a day. That's KX, all the plumbing, a rule engine, and a system that could engage off the back of the decisions we're making. We got fast-tracked for delivery because the business quite liked the idea, and we got time to value in 6 weeks. So we were able to develop very, very rapidly within the platform. Same model. In this case, though, our system of record isn't a data warehouse. We don't have to run all these cubes and what have you in the background. We're feeding directly off the live feed in the exchange. We're producing facts with KX. At the moment, as I mentioned, we're not doing ML, we're doing statistical analysis. And if you 80-20 the problem, we can get a lot of gain just doing statistics. ML is non-trivial to do well, particularly if you haven't got a labelled data set. So we picked a BRMS, just to make it easy, Drools, which actually none of us knew how to use properly, and we managed to implement it in a day in a hack, which we thought was quite cool. And then we built a thing called a Waldo. Now I have to explain this because no one ever knows what a Waldo is. You know those cool sort of remote manipulator things? You're in the submarine deep undersea and you've got the little handles, and when you move the little handle, the giant submarine arm outside works. That's what a Waldo is. It's a force multiplier that allows our system to act. So in this system, the Waldo is dumb. It doesn't do much. All it does is act based on imperatives that are coming down the pipe towards it. All our business rules are sitting in Drools, and all our maths, if you want to call it that, is sitting in KX. The platforms just do their thing in the background. Yeah. Our current record is 32 minutes to close an account, from open to close. The only reason it's 32 minutes is we've got a human in the loop approving the action. Right? Our average time to closure is actually over 300 days at the moment. The only reason it's over 300 days is we're catching accounts that the old system didn't get anywhere near catching. So they've been live for over a year, right? Stealing our data continuously. So I'm going to give you a little bit of tech. We haven't had that much tech. So this is how we kind of did the plumbing for this thing. We generate insights in KX. I've left the Exchange platform out for this. Most of our string and glue internally is via a system called Kafka. So we pump data in streams that we allow to connect two components together. So we managed to integrate KX with Kafka in a matter of a couple of hours. It uses a standard library, and KX happily supplied a little shim that we can use to talk to Kafka. It was actually quite easy, to be honest with you. So we generate facts into a Kafka topic. Then anything can consume from that Kafka topic. In this case, our Drools engine, which we embedded in a thing called K-streams, which allows you to have your little rule engine sitting there. It ingests messages from one side, processes whatever rules it's going to process, whichever rules fire, produce messages piping out the other side on a rules topic. It's our naming convention, you see. We then built a little system of engagement, our Waldo, to act upon the messages that were coming out of our rule engine. And there's kind of two things we wanted to do with that. One of them is we wanted to be able to look up reference data. So our focus when we've been integrating KX is to integrate the fast-moving streams of data. So we don't necessarily want to store in KX the P&L, the profit and loss that customers had over the last year. The data warehouse is great for that kind of thing, but we want to be able to look up the data, and we don't really want to run ETL inside the KX platform. So we don't want to do all these extract, transform, and load, and those kind of data warehousey processes to load in reference data within our platform. So instead, the rule engine can ask for more facts. So I've got an insight that this user is probably naughty. We're not quite ready to act on it yet. We need to know more about the user. So we can ask the engagement engine to give me some more data, give me a reference fact to play with. And then, of course, we have countermeasures that we can apply, things like account closure. We also wanted a human in the loop. And for this, we built one of the HTML5 KX dashboards. In fact, our resident KX guy, Dan, did so for us, which basically presents a little display and gives information about the account recommendation that we're going to make and allows one of our SMEs to act upon it. And we're, of course, keeping all of that data and squirreling it away in KX. So we've got a labeled training set that we can use to implement some interesting ML algorithms later on. You can see some pipes there on the facts and rule engine. We're actually tapping both of those for audit purposes. So to give you an idea of one of the messages that flow across there, I had to expurgate the account ID because it was an actual live message, and I don't want to really reveal that to you. That's effectively JSON that's flowing over our Kafka stream. Very simple messaging protocol, but it doesn't need to be a complex one. And we're using JSON because the amount of traffic flowing over that link is pretty low. For our internal systems, we use binary formatted messages, so we don't have to serialize and deserialize and all that sort of boring stuff. So there's a little look at the dashboard. That's what it kind of looked at. That's all just garbage data rather than actual account IDs. Give you some idea of what our SME is being inflicted with on a daily basis. Although I'm not showing it, you can click into any of those recommendations and you get a bunch of reference data on which they're basing their decision. And we've got a process loop running with the SME, so if he needs more reference data to make a decision or he's uncertain about how to make a decision in this case, he can tag it, and then our product guy, Max, who's floating around in here somewhere, has a regular slot with the guy, and we can use that to refine the business rules. And as you recall, we can do that on kind of a minute or a few minutes granularity. The reason why I'm not showing it is a little bit sensitive. I don't want to actually show you the rules we're using to decide whether people are bad or not, because I don't want to say anyone's bad in the room, but maybe slightly bad. Exactly, we're all friends. So what else are we doing? We're tying off additional market data feeds within the group. So as you can see, this is a Betfair level project. It's originated within the exchange. We're techie types. There are other platforms within our group, within other brands in our group, other brands based in Ireland, Paddy Power you may have heard of. In the States, FanDuel in Georgia, all sorts of other places. So we're looking to extend our coverage to other people in the group. We're just sort of working over our rules and our Waldo capabilities and all that sort of stuff, blending in some AI later on, or more advanced AI like ML. The design pattern has worked quite well, so we're going to start stamping that out for other solution domains. There's a few that we've got in mind. The other thing that I mentioned that sort of decision engine earlier on. The other thing we're obviously trying to do with KX is integrate its insights into our kind of federated decisioning model. So when you have an engine or a model or what have you trying to make decisions about what's going on in your business, we now are large enough that we have to fully federate that decisioning domain, break it up into subdomains, and break up the insight generation process into subdomains as well. So that's definitely KX is placed very strongly within the exchange because it's literally the only thing that can keep up with the exchange. But we're looking to put it into other platforms as well. Gonzo, I think that's me done. Thanks. Come and have a chat if you like.